Hey everyone, let's get started with the new lecture. So in this lecture, we are going to learn about C language, like the basics of it, and you will realize like how much C you already know if you already know other programming languages like Java. So you already know that this course is about like Linux, C, and assembly. So we are in the C section and it's going to be here for a while. It's going to be like 60% of the whole semester. So from now on, everything will be C focused. So yeah, let's get started. So a basic history lesson. C was made by Dennis Ritchie at Bell's Lab in 1972. My bad. So his motivation was to make a programming language that can be used to create operating systems. And traditionally, it supports a procedural view of problem analysis. And okay, so he did manage to write a like why is my uh, much better. I'm sorry about that. So yeah, he did manage to make a operating write a programming language that makes a programming language which was Unix, and the Linux we're using is Unix based. Okay, so C language basically gave birth to the operating system that is Unix, and C language is the most closest to a machine language. Okay, so the first formal language standard was adopted in 1990, and it required a lot of compromises of vast body of C was more or less like legacy code, so they had to do a lot of compromises, and later on, like 10 every 20 years there's a new convention for it. So right now we are using the C11 convention, and whenever we are running codes in this particular course, we will be using the C11 standard most of the time. It's not very different, it has just some like additional stuff to make things easier. So yeah, that's a very weird history lesson for C. So yeah, we are on to a rough start. So this is how a normal C function is going to look like. First, it will have some sort of like import statement, which we are using include. So C uses include, like in Java, you will be doing like import like scanner or something like that, or even in Python, it's import. In C, it's include, hash include. Because we have a hash over here, we call it hash include. Okay, so hash include and then a library name. Then it will have main dot like main function. Main function is the mandatory function in C. Whenever you run a C program, it starts from the main function. Whatever you write in main function is going to be executed. Whatever you do not write in the main function is going to be ignored. Okay, so here is some sort of like function, and then there's going to be a return statement. So if you did Java before, you will notice that Java doesn't have a return statement because usually it has a return type of void. But in C, you should have return type for the main, and it is int. So it's for error checking mostly. So this is how a normal C code is going to look like. Obviously, it's going to be more complex than this, but this is kind of like a tradition to start off C, and that is to start it off with hello world. So yeah, the first thing you should be doing is try running this by yourself in your VirtualBox or RLogin. The codes are given in the description below. I'm just kidding. The code is given in the page. Take a look at it. It's in a GitHub repository. I own that repository. I'm going to upload all the codes over there so that like you can just like copy paste and play around with it. So get a better understanding of it. Okay, so yeah, download the code, try to run it. So this is how we are going to run it. So I wrote this compilation code. In your terminal, you will be writing gcc, then you will be writing -std equals C11. It basically means that I want the standard C11. -w all, it means warnings. Like if there are any warnings in my code, show them to me. This is the file name. In my code repository, it's under the example1.c. So give it a try. -o, and it has a executable file name. So I'm going to name it my exec. You can name it whatever you want, and then we are going to run it. So if you declare the path correctly in your first assignment, then over here you don't need this, but it's best if you use /, and then write the file name and run it. It will say hello world. If it says hello world in your terminal, you know that you managed to run the code like without any problem. So this line is important because this is how we are going to compile every single C code. So the best way to learn C is to try it by yourself. So yeah, download the code, try it yourself, okay? Try to run it, and if you get stuck, of course, let me know, okay? So when a C compiler is invoked, the first thing that happens is that the code is parsed and modified by preprocessor. The preprocessor handles a collection of commands, commonly called directives, which are denoted by character hash. So the hash include is also a directive, and it specifies an external file. These external files are library files, okay? In the library files, we have the library functions that do all the stuff so that you don't have to do it. Those are written in assembly, and it communicates with the PC directly, and it's kind of advanced level for most of the people, most of the normal like population. So you are just given those, and you can just make use of them, and don't have to worry about too many complexities, right? The preprocessor essentially copies the content of the specified file in the place of the directive. So what happens is whenever I write like hash include stdio, what happens is here. So when I put like in hash include stdio, so it goes to the file called stdio.h, copies everything and puts it here, like replaces this whole thing with the content of the file called stdio.h. That's what happens whenever you try to compile a C code. Okay, so for example, that stdio.h has a function called printf, and it basically makes use of it in this line. So that's what is basically happening whenever you compile a C code. So the C standard library has many different functions. A C standard library includes a fairly large collection of types and functions. Okay, so like Java, C also makes use of the normal types like integer, double, float, character. It's way less than Java, and it has all these functions like printf, scanf, fprintf, fscanf. You will learn them more and more later in the lectures. The declarations of these are placed in the collection of header file, which are part of the distribution of every C compiler. You can actually go and take a look at them. If you go to /bin, and then you go to I think lib, you will actually see all the header files that C makes use of. The implementations are placed into a collection of C source files, which are then precompiled into a binary library file, also part of every C compiler distribution. You can actually take a look at the like implementation of it if you want, but most of it won't make sense. because even I don't understand what it says, because C is very complicated language, like the implementation of it. But usually its source codes are much easier to learn. Honestly, it's not. It's complicated because it's simple. I know that doesn't make sense, but that's how it is. So C programmers incorporate portions of the standard library into their program by making use of like include directives. This include directive is basically like import in Java. Like you can also write your version of library functions and you use the hash include to include them in your C source code. Okay, what's now we will be comparing C with Java. So the naming rules are the same as Java, but customary conventions differ time to time. Declaration of syntax is literally the same. The scoping rules are very similar, but it's only on file like scope. More of it will come later in the later lectures. So many reserved words are same with the same meaning, but all reserved words in C and all standard library identifiers are purely lowercase. Okay, so this line might be a bit complicated to understand. So what it basically means, like, remember all the special words in like in Java, for example, like for or while or do, or like for example const, int, and all of this. These are like similar in C. You make use of the same things in C. Everything in Java you have learned are already included in C. Java has more of those stuff. Okay, so the reserved words in C is like a subset of Java. So if you know the reserved words of Java, you already know all of the ones that are available in C. Maybe some of them are not available in C. So C is like a subset of it, not a superset. Okay. So the operator symbols and expressions are more or less the same. The basic control structures like if, for, while, do while, they are almost the same. Like there is absolutely no difference between Java and C in this aspect. Function call, return syntax, and semantics are the same as with Java. Function parameters can only be passed into a function by value. So you know you know that Java actually does a call by reference. C doesn't do that. C just does a call by value. But later you will see how to do call by reference in C. It's not as same as Java, but the main idea is more or less the same. Okay, am I forgetting something over here? Well, yes, I remember. So in Java, you usually use like public or like private, but in C, this doesn't exist. So other than that, they are more or less the same. Okay, so the conditions and conditionals and loop. So C includes if else, switch, while, for, do while. So if you know them from Java, you know them in C already. You don't have to worry too much about it. C also has a statement called go to, but you shall not go to. Okay, you have the power to use go to, but you should not be using that. That one is given just because it needs a backward compatibility with assembly. Even though you can use goto, you should not be using it, because with goto you can just go wherever you want in the source code, but C is a structured programming language, so it should maintain a specific structure, and goto kind of throws the whole structure out of the window. So never use goto. You know that it exists in C. So if in a job interview, if you are ever asked like, do you know the goto statement in C? And you will literally be answering, yes, I know it exists, but I am taught that I should not be using that. And you'll probably be hired if you answer that. But if you ever say that you want to use goto, you won't be hired. no one will like you if you do that. Trust me. Okay. So the C's philosophy is the stated goal of the designer of C language is correct code should execute as fast as possible on the underlying hardware. Of course, good programmers write only correct code, and only good programmers should be writing code. This is not a jab towards you. This is just something Professor McQueen likes to say. And I mean, you should always be focusing on becoming a good programmer, right? So you write good programs. And if you write good programs in C, they will be running as fast as possible. Okay, so C is probably the fastest higher level language ever. I don't think even now there isn't any language that executes as fast as C. So whenever there is a need for speed for any sort of program, they write it in C. For example, most of the OS even now are written in C because the OS, like operating systems, needs to be as fast as possible, and that can only be done with the programming language C. So that's why it's so important. And even now, for example, all the microprocessors like Arduino, Raspberry Pi, and whatever, they still run on C because that's the fastest way they can work with. And it also needs a very small memory, um, like it needs a very small memory. So that's why it's still used. It's a very old language. You already saw that it was made in 1972, I think. But like even now, it's very prominent and it's very important. So you know why? Because every single machine kind of works one way or another in C. If you look at the source code of Java or Python, you will still see that their main like structure is still written in C. Okay. So what are the differences with Java? So all built-in C types are primitive. Okay, there are no class in this language. So with primitive, I mean like int. Like with primitive, I mean like int, float, double, character. I don't know why it's doing that. So anyway, these are the um, primitive types that exist in C. It also exists in Java, but like things like integer and all of those stuff don't exist in C. Like the class, this thing doesn't exist. We have something called struct, but we will be learning about them later on. Okay. So there is no notion of member functions in C. So you know how in the classes you write functions, right? Like member method or something like that. C doesn't have that. Okay. A C is a collection of functions that call one another, not a collection of classes and objects that use one another's services. C doesn't have any class. Java does. Okay. So from this, you know that C is not a object-oriented programming language. In C, every variable may be allocated dynamically or not. It's up to you to decide. But in Java, most of the, well, Java is like mix and match. It's kind of like C, but like in C, you have more power over the dynamic allocation compared to Java. Scope rules are more or less the same, but they are still different. Like a name declared within a block is strictly local to that block. Okay, like in Java there will be like public, private, and protected, but in C they do not exist. Okay, in most cases C variables are not automatically initialized at all. You have to initialize them yourself when you declare them. Okay, so in Java, whenever you write a variable, it is usually initialized with either 0 or null, but in C, it is not initialized. It has some garbage value, and if you do not initialize that, it's just going to make use of that specific value. So let's see how we declare variables in C. All declared objects are by default statically allocated, not dynamically. Okay. For now, I will be talking about dynamic allocation time to time, but like, don't worry about it for now. We will be going through them more when we go through the pointers. But for now, just ignore if I say anything about dynamic allocation. Okay. So most of the allocations are going to be static in C unless done otherwise. Thus, the following declaration results in x and y being a object of type int, not reference to that object. Okay, so in C, you won't be using references directly. You have to specify them explicitly. So I have two variables x and y, and they have the value 6 and 28. So this has many consequences. Okay, assigning x to y does not result in an alias. Rather, x becomes a copy of y, but is still an entirely different object, just like Java primitives, but unlike Java objects. So if I write something like x equals y, I'm basically copying this value in x. If I make changes to x, y is still unaffected. Okay, so it's like the primitive objects in Java, but not like the classes of Java. So using x as a parameter to a function does not allow the function to modify x because it's a call by value, not a call by reference. Logically, you can only initialize declared object to 0 if they are numeric types. But in C, the 0 and null is interchangeable. 0 means null, null means 0. There is another thing which is /0, which also means 0, which also means null. So these are interchangeable. Sometimes I will be mentioning one and I might mean it the other thing. Don't be confused, okay? So automatic variable initialization, variables are not usually automatically initialized. They usually have garbage value and you do not know what the value is going to be. For example, if I try to run this code, I'm trying like int x, y, and I didn't initialize any value to it, right? And I'm trying to do something like y equals 2 into x plus 1. But we don't know what the value of x is going to be. And then what is going to be the value of y. If you try to run this code, it's going to be a weird value every time. So whenever you're working in C and you have like variables, make sure you explicitly declare them something. Otherwise, they are going to be having a very weird output and you do not want that. Yeah, this is a very common source of error in C programming, and you should always be careful about it. Also note that when Linux allocates memory to a process, it may, right? This is very important. It may do that. It's kind of based on luck, and honestly, you shouldn't be relying on luck when you're working with C, because C program is always used in the most delicate stuff. So if you want to be a C programmer and work with very delicate stuff, you should be delicate with it, and you shouldn't be, leaving everything to your luck. So yeah. So it may write zeros into the memory, which has the effect of initializing variables stored within that memory to 0, but you shouldn't be counting on that, okay? So if you ever do static global initialization, they are going to be 0, okay? And you do not need to initialize them. We will be explaining what the static globals are later on. So later in the C standard, especially C11, the bool type was included. Before bool wasn't included, the value of false was just 0, and the value of true is not 0. Like any positive or negative value is considered true, but like if it's a 0, then it is false. But later on we have the bool type in C. So like for example, if we do any sort of expression like this, it's going to be either true or false. Okay. So in C we have the primitive types. These have some modifiers. So this stores single values and most definitely not objects in the Java sense. In particular, there is no guarantee of automatic initialization. So yeah, never depend on the automatic initialization. Okay, it's mostly going to be garbage, but in Linux it might be initialized with 0. But again, do not depend on that. Okay, so it has some modifiers. For example, you have int, you have unsigned int, and you have like short int. And look at like what these modifiers are doing. Like normal int is always going to be 32-bit. Well, not always, because like if you think about PCs 20 years ago, at that time int basically means 16-bit. But now most of the int are going to be 32-bit, and maybe later on they are going to be 64-bit. Okay. So there is unsigned int, which is also 32-bit, but later in this course you will know what that unsigned actually means. There's going to be short int, which is 16-bit. There are unsigned short int, which is 16-bit. There's going to be long int, 32-bit. So like I said, in the 20 years ago, if you used long int, that was going to be 32-bit. But if you just used int, it's just going to be 16-bit. There is unsigned long int, which is 32-bit. Float is 32-bit, single precision type. Double is 64-bit, double precision type. Also, you can also use like 64-bit, which is long int. That one is 64-bit. So if you use the std, oh my god, I kind of covered everything. So if you're using the std int.h, you can also use this instead of the modifiers. Okay. Can I clear them? Nope, I cannot clear them. I'm sorry. So yeah, okay, that works. So you saw in this page like there are like ones with modifiers, but you can also use this. So let's see what their ranges are. So if you're using int 8, it's going to be 8-bit, and its minimum value is going to be -128, and its maximum value is going to be 127. So why is it not 128? When you learn the assembly part, it will make more sense to you. But for now, you can just assume that 0 also, like the value of 0 also needs like 8-bit. So it's taking one part from the positives. So that's why it stops at 127 and not 128. So if it's a uint, which means unsigned integer 8-bit, in that case, the lowest value is going to be 0, the highest value is going to be 255. So you unsigned basically means there are not going to be any negative values. So that's why it starts from 0 and it ends in the highest number you can get to. There is int 16, so it means 16-bit. So this is the lowest value of 16-bit, and this is the highest one. If we are using unsigned, it starts from 0, ends here. Same for 32-bit. Again, unsigned 32-bit. This is the 64-bit one. So yeah, whichever integer you're using is very application based. Like whatever you need to use, you will be using that specific one. Usually I just go with int because I'm super lazy, but you should be making use of them so that there aren't overflows or underflows. Okay, in many of the assignments you will actually be facing them. So yeah, I hope those assignments will help you learn this stuff. Okay, there are other primitive types in C, like character, unsigned character. So character has the size of 8 bit or 1 byte, and it holds the ASCII code. You can just go to Google and search for like ASCII table, and the table you see is basically the range of character. Unsigned character doesn't make much changes, and in C, one thing is very interesting is character type and integer types are interchangeable. So if you have a type like a character A, and you try to use it as an integer, it's going to be 97. And if you do something like A plus 1, it will be 98, which will be D, and so on. Okay, so that's a very important concept. So yeah, sorry. So the arithmetic operators in C is exactly the same as Java. Semantics are generally the same as well, although the C standards leaves the result of a number of unwise constructs undefined. For example, this is kind of undefined, you shouldn't be using that. So if you want a very detailed of how it's going to work, take a look at this link. My take on that issue is that such expressions are generally stupid and unlikely to be used in real code. So yeah, you shouldn't be using that. Precedence rules are same as Java. Precedence can be forced and disambiguated by using the parentheses. So basically, the arithmetic operators in C is exactly the same as Java. Okay, so if you know the Java, if you know the Java one, you know the C one. So now let's take a look at the you know, structure of Java, and let's compare that with C. So in a Java code, we have something like public class and the class name. We have private int top, private int bottom. We have a member function, right? But in C, we do not have anything called class. Instead, we have something called struct. You don't have to worry about struct for now. We'll be learning that later on, but I'm just going to show you the similarities or dissimilarities between these two. Okay, as you can see, there is no public, there is no private. Okay, and the function is not inside the struct, it's actually outside of it. Okay, and as you can see over here, we had a constructor. It doesn't have any constructor either. Instead, you have a function to make use of it. So yeah, in like C is like Java, but it's like broken apart version of it. Okay, let's take another look at it. So yeah, like I said, you already saw it has like member functions, but C, there isn't any member function. It has to be a something outside of it. Okay, so everything has to be defined separately. There is the power of memory management in C. In Java, garbage collector takes care of everything, and it's very unreliable. You do not know when it's going to be collected or not. But in C, dynamically allocated memories are not deallocated automatically. You have to take care of it by yourself. Otherwise, there's going to be memory leak. So one particular example I like to give about it is that from the game Bloodborne. So Bloodborne is a PS4 game, and when the game came out, it had a specific problem. So if you left the game open for 12 hours straight, the enemies would stop working because of the memory leak. So basically, the developers of that game forgot to clean the memory. So what happened was after 12 hours, it would just clog the whole memory, and the AI didn't have enough to work with, so they stop working. So that kind of shows what happens when memory leaks happen. The stuff stop working. So that's why when you're working with C or C++, you have to be very, very careful about the whole memory management. Okay, like how to allocate them, how to deallocate them. Okay. Honestly, it just shows you the difference between the memory allocation. I won't get too much into it, but like in Java, there is like new, but in C, it's something like malloc and size of it. You have to also remove it using free. Don't worry about it for now. I'm going to cover them later on. This lecture is more of a like introduction to C, like what stuff are there and stuff. So yeah, for now, just like roll with it. Okay, so let's see what dynamic allocation and static allocation has in difference. So dynamic allocation, memory for object is requested by explicit call in code executed at runtime. So nothing was made when it was compiled. Decision of whether to actually create an object can be deferred until runtime. Requires call to OS function may be slow, request may be denied, because if you do not have enough space, you won't be able to dynamically allocate it. Raises issue of disposing of memory once the object is no longer needed, because you have to explicitly free it, otherwise the specific memory leaks are going to happen. So static allocation, memory for object is requested by presence of an object declaration in the code. So whatever you wrote in the code, that is going to be statically allocated. Like a space for that is going to be set up from the beginning. Decision whether to create object is made when the code is written. Memory allocation is automatic, only denied if the program is out of memory. Like if it runs out of all the space it was given at the beginning, only then it will not have enough space for the static allocation. Disposing of memory is handled automatically. It's basically the auto scope from Java. Like whenever you go outside a block, that memory stops existing. Well, pointers, don't worry about it for now. It's just an introduction, but pointer is basically the hardest concept of C to understand. I will be covering that later on. It's just an introduction, okay? So a pointer is simply a variable whose value is the address of something. When we allocate a object directly, we get an address, okay? In Java, this is a Java code. And when we do that, by doing this new, we are actually getting a reference to that variable, okay? And we're putting that into R1. It is kind of like a pointer, but not a pointer, okay? In C, variables are declared by using some syntactic sugar after the type specifier. You will be seeing this a lot when we are going to talk about pointer. This is basically a pointer like directive or symbol or whatever you want to call it. So whenever we do malloc, we put that into a pointer, okay? So yeah, this was just a basic overview of what C program looks like, or the basics of it. We will be seeing more of it soon enough. So yeah, that's it for this lecture. I'll see you in the next one.